Welcome to my channel. I'm Irfan, and in today's video, we are diving into something super interesting and very relevant in today's data-driven world: data warehousing and data mining for vehicle insurance prediction. We'll be exploring how large amounts of vehicle and customer data can be stored, processed, and analyzed to make smart predictions like whether a person is likely to buy a vehicle insurance or not. This video will take you through what a data warehouse is and why it's useful for this kind of analysis. How data mining helps us extract patterns from data warehouse. And finally, we'll go through a complete Python projection that predicts vehicle insurance purchase behavior based on customer features using machine learning. So, if you are a data enthusiast, a student working on projects, or just curious about how data is revolutionizing industries like insurance, you are in the right place. Make sure to like this video if you find it helpful. Subscribe for more data driven content, and let's get started. All right, let's get started with a part one of our vehicle insurance prediction project using data warehousing and data mining techniques. Now let us move to a code. Yeah, now we are into our code. In this code, the step one. Step one is importing libraries and loading the data. I begin by importing the essential Python libraries like Pandas for data handling, Seaborn and Matplotlib for visualization, and Sklearn for machine learning. Then I load two datasets, one for training and other for testing, using pdread CSV these files. These files contain customer information like age, gender, age, gender, driving license status, vehicle damage, and whether or not they bought insurance. Now here is the step two. In step two, next comes data processing. Next comes to data cleaning and pre-processing. I convert the gender values from text to numbers. Female becomes 0 and male becomes 1. And I use one hot encoding to handle categorical variables like vehicle age and policy sales channel. I rename the vehicle age columns. In step two, here I rename the vehicle age columns. And coming to the step three. In step three, train, test, and split. In this, then I separate the target variable called response, which tells us if the customer bought insurance or not. Using train test split, I divide the dataset into training and testing sets so we can evaluate the model's performance later. And now let's begin to the step four. In step four, random forest with hyperparameter tuning. Now let's talk about the first machine learning model, random forest classifier. I use randomized search CV to automatically tune hyperparameters like criterion, maximum depth, and minimum samples per leaf and split, and number of trees. This helps the model performing better without manually guessing the best values. Now let's move to the step five. In step five, we are talking about model training and evaluation. Once the model is trained, I use classification report to print the accuracy, precision, recall, and F1 score. I also calculate the ROCAUC score to see how well the model distinguishes between classes. And then finally, I save this trained random forest model using Pickle. So we can reuse it later without retraining. Okay. Now, after completing this step, here is the final output of our code. In this code, we can see that fitting 4 folds for each of 10 candidates, totaling 40 fits. Then the precision will be 0. For 0.92, and recall will be 0.66, F1 score will be 0.77, and the support will be 12157. In the second state, the precision value will be 0.73 and recall is 0.94, and we can see F1 score and support also. So based on this, we can say that area under cover AUC is 0.85 after calculations. And the logistic regression of this code is given a area under curve will be after calculating just like above, we are getting 0.839, so on. And the gradient boosting classifier. In this, the pressure is 0.91 at one stage, and another stage the pressure is 0.73. And the recall is 0.67, and we can see upon score support for all this. And the AUC we got in the final is 0.56. And then we are moving to the second code, wrap up of part one. And in this code, we are gonna say that part one of this project we have done data pre-processing and built our first predictive model using random forest. In the last part, we built our first model using a random forest with some basic evaluation. Now we are taking things a step further using a balanced training data set and visualizing the performance using an ROC curve. And in this, the step one say the step one defines of this code is just like before. I start by importing the libraries and reading the training and testing CSV files. I process the columns again, convert gender to zeros and ones, apply one hot encoding for categorical features, rename and convert columns related to vehicle age and damage, and and drop the unnecessary ID column. And step two. Here is the step two, and I am going to explain about in this step two. We are going to learn. I also define the target variable response and split the data into training and test sets using train test split. I'm using the same hyperparameter tuning setup as before, but here the training data has been balanced to ensure both classes, people who buy insurance and those who don't, are fairly represented. And here in step three, we are going to learn about training the random forest model. And in this step three, I trained the random forest model using a randomized search CV, which helps us automatically find the best combination of hyperparameters. After training, I use the classification report to check metrics like precision, recall, and F1 score, which tell us how well the model is performing. And here comes to the step 4. In step 4, visualizing with the ROC curve. In this now comes to the best part, which is visualization. In step 4, I calculate the model's probability scores and plot the ROC curve using matplotlib. The ROC curve shows the trade-off between precision and recall at different thresholds. We also compute the area under the curve or AUC, which gives a single value to summarize the model's ability to distinguish between the classes. The, the closer AUC is to one, better the model. Here you can. Okay, now let's come to the step 5. In step 5 is the saving the model. Once satisfied with the model, I save it using pickle with the file name rfbal model save. Yeah, you can see it here. rf rfbal model save, so it can be used later in a real-time application or in the script. Okay, now comes to now let's wrap up of part 2. And that's it for part 2. We have now trained a random forest classifier or balanced data and visualized its performance using an ROC curve. Now the output of this second part is fitting 4 volts for each of 10 candidates, totaling 40 bits, precision, recall, and F1 score and support. Here we can see here is the precision, recall, F1 score, and support are given, and then the accuracy and macro average and weighted average are listed here. And now let's move to the third part. In this third part, we can say that in this part we are going to use the random forest model we trained earlier and build a real-time prediction system that takes inputs from the user like their age, gender, driving history, and tells them whether they are likely to buy insurance or not. Now let's come to the step one. In step one, we are gonna collect the user's input. We start by asking the user to enter details such as age, gender, whether they have a driving license, their region code, whether they had a previous insurance, age of the age of the vehicle. And we are in this we are gonna add on some like vintage, annual premium, whether the vehicle is damaged, policy, sales channel. These inputs simulate what a real customer might what a real customer might fill in a form when buying vehicle insurance. And then we can move to the step two. In step two, once the user enters all details, the vehicle checks if the data is valid. For example, is the age realistic? Did they type M or F, like male or female? For gender, did they enter numbers for expected? This validation ensures that the model receives clean and safe inputs. In step now let's move to the step 3. In step 3, next I convert all the text based values into the format the model understands. For insurance, for instance, gender male becomes 1, female becomes 0, vehicle damage y becomes 1, vehicle age is mapped into two binary features if it's less than 1 year or more than 2 years. Okay, now let's move to the step 4. In step 4, we are going to learn about the loading the trained model. In this step 4 I have done, I loaded the trained random forest model using pickle. This is the model we saved earlier as RFBL model save, if you remember. Then I used the model to make a prediction using the predict function. And now in step 5 of this code part, I showed the prediction result. Finally, the script checks the prediction. If the prediction is 0, the output says you are not likely to buy a vehicle insurance. If the output is 1, then it prints the I think you will buy a vehicle insurance. Else it will print invalid input. And then let's wrap up the part 3 with this output. You can see the output given. In this we have entered our age, enter our gender. Do you have a driving license? Yes or no? Which region do you belong to? Something we have given something. Do you have a previous insurance? Yes or no? How old is your vehicle? You can enter number of days, and these all the inputs you should enter, and then we are gonna get the output according to that. And finally, after entering these such as etc inputs, we got an output such as you are not likely to buy vehicle insurance. And then let's move to the final part of our code snippet. In this final part, we are going to take a sample from our original datasets and see how our trained model performs on multiple records all at once. Let's dive in. Okay. You can see in step 1, reading a sample from the datasets. In this part, I am reading only 10 rows from the main dataset using pandas. Read CSV with skip rows and end rows to limit the number of records. This simulates the real world use case. Maybe you are building a dashboard where you want to make predictions for a few customers at a time. So in step 2, we are pre-processing the data. Just like before, we pre-process the data, convert gender to 0 to 1, okay, 0 to 1, and then one hot encode categorical variables using get dummies as an input, and then rename some columns for consistency, convert all the necessary values to integers, drop the id column and the response column since we are trying to predict it now. This is exactly the same pre-processing pipeline we used for model training. And then let's move to the step 3. In step 3, we are gonna load the trained model. I load the trained model, which is our random forest model that we saved earlier using Pickle. This allows us to reuse the model without retraining, super useful for production apps. And the final step, we are going to make batch predictions. Now I run model predict on the 10 records we just processed. The output is a list of predictions, either 0 or 1 for each person in the data. You can see here. Output is listed here 0, 0, 0, 1, 1, 1, 0, 0, 0. If it's one, the model believes the person is likely to buy insurance. If zero, they are probably not interested. Now let's wrap the end of this quiz. Now I'm gonna explain you about Power BI now. In Power BI model, I am gonna explain you this. Okay. In this, I'll walk you through a beautiful Power BI dashboard built using the same vehicle incident data we have been working on. In this dashboard highlights, we can see the top left is a response breakdown by gender. We can see that out of those who responded positively are 61%, and who and 61% are male and 39% are female. This tells us that male customers were slightly more likely to respond positively to insurance offers. And top middle. Okay. Now I'm gonna talk to you about the top middle policy sales channel versus response. In this chart shows the relationship between the sales channels and customer responses. It helps us understand which channels were more successful in convincing the customers to purchase the insurance. Now, top right, total positive responses. Out of the full data set, we had found around 47,000 positive responses. This is our key target group when it comes to customer conversion. And bottom left, in bottom left, vintage versus driving license, we can see the graph. Here we are looking at the sum of days customers have been associated with the company means vintage, and how many of them have a driving license. It's no surprise that almost all respondents had a valid license, something essential for vehicle insurance. And now, let's talk about the bottom middle. Here it says that previous insured versus vehicle damage. This pie chart is very telling. What a 94% of the customers with